Okay, so today's lesson, we're going to find the median of a distribution, calculate the mean. Again, this is quantitative data, so these are numbers. Makes sense. Okay, so the median. So we've just kind of like briefly touched on it. It's the middle value. If there's an odd number of terms, there's going to be one value in the middle. If there's an even number of terms, there'll be two that are in the middle. We'll have to average the two of those. But again, it's a measure of center is what a median is. So it's the midpoint of a distribution. Half the observations are smaller, half are bigger. Arrange the data first from smallest to largest. If it's odd, I just said that. If it's odd, it's going to have one median. If it's even, it'll have two in the middle, and you have to average them. For small set data, absolutely just find it by hand. Okay, so fiddler crabs feed by scooping food into their mouths. Researchers observed one species of fiddler crabs in National Park in Indonesia. Here are the feeding rates in scoops per 30 seconds of 20 different species. One thing did they organize them? They did not organize them by smallest to biggest. So that would be your first step. I mean, you want to put them in order. So you'd have to, if you did this by hand, this would be a tough one to do by hand, but if you do it by hand, definitely put them in order. So there's 20 different crabs. So if you get your calculator out and do 20, we don't really have to use our calculator. This divided by 2 is 10. So because there's an even number, I know there's actually two terms in the middle here. So I think it's the 10th and the 11th. So I would count from left to right here, or right to left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looks like the 10th term is 58. The 11th term is 59. So right in the middle, if I cut right in the middle, it kind of splits the data into two pieces of 10, two groups of 10. And so between 58 and 59, the median would be 58.5. And we got it. I'll show you how to do this in the calculator because again, you're going to use this. You might as well learn it if you haven't yet. So this is about crab, so I'm going to call it crab. And I'm just going to type in the data as it is, like as it's given to me. Okay, so I always like to check and make sure I type the right number. It does say 20 right there. You make sure your cursor is out of that cell. I like to add a calculator page at this point, not a scratchpad, but Control Doc, add calculator, because those pages will talk to each other. Go to menu, got to be in stats, got to be a stat calculation there, and there it is, the very first one. So menu 611 is one variable stats. You press enter. The name of the list was called crab, and I'm just going to say okay. And it gives me a whole bunch of information here. You have to scroll up just to see the top part of it. X bar is the mean. So the mean would be, if I read that right, 55.5. The next symbol there is the sum, or a capital sigma there is sum. The sum of all the x values is 1,110 if you want to add those up. The sum of the squared values, something we use for regression, is that. SX is sample standard deviation, it's 15 point something there, and population standard deviation is 14.7. And then it gives the 5-number summary at the bottom. So the 5 numbers, we use this in box plots later in the section here. So N is the number of terms, minimum, Q1, median, Q3, and max. So median is indeed 58.5. Just a different way of getting it. I want you to know both ways, actually. So I think it's good to know both ways. It does take a bit of time. If there's this many numbers, it takes a bit of work to find the median because you have to order all the numbers first, especially. So mean is the average. It's also a measure of center, a different measure of center. So you get that by adding up all the terms and dividing by the number of terms. They wrote it really fancy there with X bar, but the thing I definitely want you to know, X bar is the mean. Like when you see X bar, that's the mean. That symbol sigma just means the sum of all the X values. You're adding up the X values and dividing by n the number of the terms. Is this the same question? Here are the feeding rates of that. Calculate the mean. So again, we already did this on the calculator, because in the calculator, when we did one variable stat, you can see the X bar is 55.5. But if you want to do it by hand, or I guess you'd add up all the terms and then divide by 20 the number of terms, and you'd get 55.5. The researchers excluded one crab with an unusually high feeding rate of 127 per 30 seconds. Calculate the mean feeding rate for all 21 crabs. What do you notice? So they added a crab to this guy, right? So we already know from our output of one variable stats, the sum of all the current X values is 1,110. I also could get that, sorry. I also could get that on the calculator by taking the average, which was, let's see, 55.5 times 20, which is 1,110. I'm pretending they're all the average there. So if I add one more piece here, so one more crab, 127, and now divide by 21, I get that number, 58.9. Yeah, 58.9 for that. So it's just a matter of adding those up. And you can see using the calculator, it's a bit easier. Also could have done this. I could have gone back to the previous page, Control Enter, put the 127 at the bottom of the list, add another calculator page, go menu 611, choose crab, and it will find the mean and the new median. There will be a new median because now there's one term in the middle. So the middle term would be 59 there. Again, just showing you different ways of using your calculator there. Oh, we already did that. When we refer to the population mean, we use this Greek symbol mu. The Greek letter is pronounced mu. Symbol X bar is for the sample statistics. So that's the mean of the sample, whereas Greek letters always go to the population. So it's a parameter of the population. Remember, parameters go with populations, statistics go with samples. We almost always use Greek letters. The only exception is we don't use pi for a Greek letter, even though it is. We use p, just the letter p for that one when we get to proportions. Okay, population mean is mu. They're just, again, just learning the notation of stats here. So the sample mean is X bar, the population mean is mu. Mean is not resistant to extreme values. It's going to be very affected by outliers. We'll talk more about that, I'm sure. Resistant if it's not affected by extreme data values like outliers. So feeding rate in scoops per 30 seconds. I guess this is the, maybe the original data. Looks to me like it might be. 55.5 without the 127. When you add the 127, is that an outlier? I feel very confident in saying 127 is an outlier. It's way out there. We'll learn how to define outliers later, but just trust me, it is way out there. So the mean went from 55.5 all the way up to 58.9 just because of one value there. That outlier caused major influence on the mean. The median did not change much, by the way. The median was, I think, 58.5. It went to 59, so it changed a teeny bit, but not much. The mean changed much more, which is what an outlier does. It may or may not even affect the median, but it'll definitely affect the mean. The mean is not resistant. So it's not resistant. It's very affected, in other words, by that outlier. So we're not going to do this here right now, but that's one way to do it. Compare the mean and median. Will the mean and median of distribution be approximately equal? If it's symmetric, that's true. Depends whether the shape is or if there's any outliers. So outliers, probably not. So you can see like the middle data there, the 23.5 median, is very close to the mean of 22.96. Because that data is approximately symmetric, the mean and median are pretty close. They're within just a few hundredths there. You can see that when the data is skewed to the left, like the first one, the mean was 19, the mean was 18, the median was 19. That's a pretty big difference. Same thing for the skewed to the right. The median was 3, the mean was 4.14, so quite a big difference there. So when the data is skewed, we really prefer using the median. That's not on here, but it's something you need to know. When the data is skewed to the right or left, we always use the median for measure of center. When the data is somewhat symmetric, we're going to use the mean. That's the better choice. Again, if it's roughly symmetric, the mean and mean will be pretty similar, pretty close. Roughly similar. Depending on the direction of the skewness. So when it's skewed left, the mean is going to be smaller. When it's skewed right, the mean is going to get bigger because it's greatly affected by the outliers. So again, mean is, it gets pulled towards the skew, towards the outliers. The mean gets pulled towards those outliers, whichever direction they're in. Good. That's the lesson for today.